Well, good morning, everyone, and welcome to the Fiber Broadband Association's Five for Breakfast. We're now in our 48th episode of 2023. Before we kick off, I'd like to thank Wesco, the platinum sponsor for Fiber for Breakfast, and our gold sponsor, Network Connects. This morning, the Fiber Broadband Association issued two press releases. First, Job Corps has approved the Fiber Broadband Association's Optic Path program as the primary fiber optic technician credential. With over 120 campuses across the U.S., Job Corps is positioned to become the second largest producer of our Optic Path graduates, helping to develop the technical workforce needed to connect every community to fiber broadband networks. Second, the Fiber Broadband Association is celebrating TIRAP's milestone of signing its 100th employer partner. So TIRAP is the Telecommunications Industry Registered Apprenticeship Program, and FBA supports TIRAPs in its accomplishment in improving the quality of training and safety for the broadband workforce. The Fiber Broadband Association's Debbie Kish, the Vice President of Workforce Development, sits on the TIRAP Advisory Board. In Washington tomorrow, the House Energy and Commerce Committee will hold an FCC oversight hearing. This will be the first oversight hearing this Congress will have since the FCC has all 5 seats filled. So comments responding to the FCC's Section 706 Notice of Inquiry are due this Friday, December 1st. The Fiber Broadband Association will be responding. This NOI evaluates the state of broadband across the country, considering several critical characteristics of broadband deployment, including affordability, adoption, availability, and equitable access, when determining whether broadband is being deployed in a reasonable and timely fashion to all Americans. The NOI also renews a push to increase the national fixed broadband standard to 100 megabits per second download and 20 meg upload. The FCC previously set the broadband standard at 25 by 3 in 2015 and has not updated since. The NOI proposes to set a national goal of 100 gig by 500 meg for the future. We believe the FCC's broadband goals are a bit underwhelming, and we will encourage a little more vision in our comments. As we look forward to 2024, we've had an overwhelming positive response to our schedule for our regional Fiber Connect workshop road tour planned for next year. Our upcoming Fiber Connect workshops will be in Richmond in February, in Little Rock in April, and Park City in June, Des Moines in September, and Albuquerque in November. And then our big Fiber Connect 2024 conference will be in Nashville, July 28th to 31st. The Fiber Broadband Association, along with NTCA and Cartesian, have released our version 3.0 of the Broadband Infrastructure Playbook. If you want a copy, you can download it from the QR code on your screen, or you can visit FBA's website under Resources. That brings us to today's Fiber for Breakfast session with Mike O'Day, the CTO of Corning Optical Communication. He's going to be discussing artificial intelligence powered by fiber-rich networks. But before I formally introduce today's guest, I'd like to introduce David Norris from our team, who's going to walk us through some housekeeping items.
Great, thank you, Gary, and good morning to everyone who's joined us. Before we go over a few logistical items, we'd like to once again thank our platinum sponsor of Fiber for Breakfast, Wesco, and our gold sponsor, Network Connects. Now, if you would all please keep in mind, all participants are in listen-only mode. To ask a question, please type it into the question box located within the control panel on the side of your screen. We will host a Q&A session with our panelists at the end of today's session. This session is also being recorded and will be available to FBA members on the FBA website within 24 to 48 hours. You can find the recording in the Events tab under the Fiber for Breakfast drop-down option. And at the conclusion of the presentation, you'll be prompted to complete a brief feedback survey. Please take a moment to do so. We appreciate your input. Now I'll pass it back to Gary to introduce our guest and get us started. Gary?
Thanks, David, and good morning. I'm Gary Bolton, the President and CEO of the Fiber Broadband Association. Last week on Fiber for Breakfast, our guest was Jeff Wabick, the CTO of DC Blocks, to discuss fiber and digital infrastructure growth in the Southeast, a real-life story. Today on Fiber for Breakfast, our guest is Mike O'Day, the CTO of Corning Optical Communications, is going to be discussing artificial intelligence powered by fiber-rich networks. Mike is the Chief Technology for Corning Optical Communications, and he's responsible for leading the disruptive innovation programs and adoption by customers while aligning the optical fiber, cable, and connectivity R&D organizations to deliver innovation required for growth. Mike joined the Corning family upon leaving the U.S. Army in 1998. Most of his career had been spent managing Corning's optical connectivity products, helping launch fiber-to-the-home product lines in support of Verizon's FiOS initiative. Mike hails from Northern Missouri and received his undergraduate degree from West Point in 1991 and his master's in business administration from Minnesota State University in 1998. He has spent 7 years on active duty as a field artillery officer, primarily in the 4th Infantry Division and the 29th Artillery Regiment, participating in training and peacekeeping operations after the Persian Gulf War in 1991. So thank you, Mike, for your service and welcome. And for audience, please type in your questions as we go, and we'll work them into the Q&A at the end. So let's get things started, and I'll turn things over to Mike.
Gary, thank you for the introduction. And I would just say, as we get started, we are super grateful for the invitation. All of us at Corning appreciate our longstanding relationship with the Fiber Broadband Association and all the work that you're doing. As Gary mentioned, I'm part of the Corning Optical Communications business, where we deliver solutions for growing markets like fiber to the home and data centers. And we're proud of the breakthrough innovations that our industry has moved our industry forward, starting with the invention of our low loss optical fiber from Corning more than 50 years ago. So we've been at it a long time. Now, all of you know firsthand how fiber is taking center stage in the ongoing work in bringing high-speed connectivity to homes, businesses, communities around the country and around the world. But what many people may not realize is that fiber is also playing a pivotal role in another fast-moving technology trend inside a data center, and that trend is artificial intelligence, or AI. And today I'll just share simply a perspective from Corning, how AI is quickly driving the need for more optical connectivity, and in doing so, what happens is that it creates the need for new applications across many vertical markets and industries that consumers and businesses will use. And those applications, of course, will require more broadband access and connectivity, something this association and many of the attendees on the call today know quite a bit about. So with that said, Mia, if we could go to the next slide. And I thought I would just start simply with a perspective that's shared in many forums about how AI is beginning to impact our lives. And what we think is that we're at a moment when AI is becoming an integral part to a wide range of industry sectors that affect both currently and in the future how we come to work and the work that we do. Some of these applications are in use right now, but most or many others are in their infancy or even yet to emerge, and all have the potential to change how we work and how we live. And I'll just briefly touch on a few examples that aren't necessarily specific to what we do at Corning, but in general affecting our daily lives. In the field of healthcare, for instance, AI holds the promise of helping doctors and clinicians in their life-saving work to help detect abnormalities in medical imaging, as an example, or helping oncologists make more sophisticated data-driven cancer treatment regimens for those battling cancer. Educators, for instance, can customize content to individual student performance, driving tutoring systems that adapt to students' strengths and weaknesses, and offering sort of personalized coaching and help on the learning spectrum. On the factory floor, and manufacturers, one that is near and dear to our heart, leveraging AI tools to inspect and identify defects in real time, either replacing mundane tasks that we use operators to do, getting more efficient with that and getting more output, for instance, in our fiber making process, using the use of AI and generating output on existing assets. In finance, AI helps protect against unauthorized transactions. There's examples of that. I think we all appreciate that on fraud detection, and also new tools for portfolio management and other investment considerations. I think if you just watch things that pop up on social media, Warren Buffett claims to use AI, and that's how he is making his investment choices now. So we'll see. He's had a lot of success, so I'm not sure I would change. Now, if you get into the transportation area and stuck in traffic on a regular basis, you can appreciate how AI holds the potential to dramatically improve traffic flow through AI-enabled traffic signal control systems that adjust signals in real time and helping reduce congestion and improve the overall flow of traffic. And then one I don't have on the screen, but I would just mention, and I know recently in one of the Fiber for Breakfast installments, quantum computing was discussed. And, I think unlocking even potentially more possibilities in the realm of generative AI as quantum computers can process a vast number of possibilities at the same time or simultaneously. It potentially speeds up these AI algorithms and models to process even larger data sets even more efficiently. And that just then unlocks and unleashes more applications to change the way that we work and live. So it's an exciting time. In some ways it's a scary time because we're not quite sure, computers replacing what humans have traditionally done in many ways can be a little daunting, but I think the potential is unlimited and can be used to make the world a little bit better place. So let's talk a little bit, if we go to the next slide, just a little bit of background that many probably know as well as I do, but this is happening at a much faster pace than many anticipated. And I'll share that in the subsequent slides and the impact of that in the optical connectivity domain and how do you build an actual AI network, which is where a ton of effort and challenge exists at the moment. But if we just take a step back for a few years, all this growth in AI is really starting to accelerate. Consider ChatGPT and its successive transformations in just the last few years. It was in 2020 that GPT-3 was introduced with far more extensive capabilities than earlier versions. The original GPT introduced back in 2018 had 117 million parameters, which are the learnable elements of the model during the training process, while GPT-3 in 2020 was introduced with 175 billion parameters, making it one of the largest language models in existence and representing a substantial leap in scale and capability. And if you fast forward November 2022, ChatGPT released to the public about a year ago, in fact, and to say it attracted a lot of attention is an understatement. 2 months later, it had reached 100 million users, and by February, just a few months later after that, reached over 1 billion users. And in March, the release of GPT-4 was announced, which continues to improve the AI or the ChatGPT's capabilities. And so it's very interesting, and all I would just say is it's moving super fast, and that causes tremendous strain then on building an AI network inside of a data center. And so what's happening, GPUs or graphic processor units are in high demand. A couple of companies, NVIDIA notably, really working hard to supply the GPUs that are required in servers to enable these large language models that are being built and used by both consumers and businesses alike. Okay, so if we go to the next slide, maybe a little bit more core to the fiber optic domain, and what we know a little bit more about from the Corning perspective is what happens inside of a data center to enable all of this artificial intelligence capability, as well as cloud computing that continues to grow and people still continue to use. Let me start with just a traditional cloud compute network and what we're typically familiar with or have been familiar with in a hyperscale data center environment. Typically, these hyperscalers will build a campus and interconnect it with high fiber count, fiber optic single mode cables. And these cables are now ranging from 1,000 to well over 3,000 fibers in a single cable that connects the building. You kind of see a campus in the top left of the screen or on the picture, the left. And those are not a long distance, maybe a kilometer or two, but they may have 3,400 fibers in them as well. This fiber comes inside those data centers and routes to spine and leaf switches that are meshed together that create what I would say an incredible number of optical links and connections inside the data center to traditional processors that are located in server racks throughout the data center. And when done correctly, these networks enable familiar uses like streaming Netflix or surfing on social media platforms, for instance. And now to enable the AI network, the network you see on the right-hand side, think of this still in the four walls of the physical construct, clusters of powerful servers with many GPUs are needed that require a high number of connections. And this, we call that an AI cluster, or AI clusters is a common term where these servers are being built, get connected back to the primary cloud network and routed appropriately back out to the internet, essentially. And the amount of electrical power then that's required to fire up these AI server clusters is significantly more than on the front end if you were to compare for a comparable number of servers that are being deployed. So that's a little bit of how the AI network works. It's a network that does connect to the traditional cloud compute network, but it's full of AI clusters that have tons of servers with GPUs that do all of the computing, really a high powerful set of computing power that takes place in an AI network. And so if we go to the next slide, what you'll see on this slide is really the amount of capacity that's being planned and starting to be deployed. We're seeing leading hyperscalers today design and build data centers with the second optical AI network, which increases optical connections by up to 5 times more inside of a data center. And as this chart shows, our analysis projects that significant growth in the capacity deployment between now and 2027. You'll see the dark blue is traditional cloud compute, which continues to grow. And then the lighter shade is the AI network, the amount of megawatts on the y-axis that have to be deployed to enable both the cloud compute and an AI optical network. The industry's tracked megawatts, by the way, for years. It's a good surrogate for how much growth is being deployed, and this will continue into the future for sure. It tracks and it is correlated well with the size and compute capabilities within a data center. One new metric that I think will emerge in the coming months is the number of GPUs being deployed, because that will begin to help the industry understand the AI compute power and optical links required to build an AI data center. And so by 2027, you'll see that the number of megawatts deployed for AI, that AI network, if you will be on par roughly with those required to support the traditional cloud compute applications, which also continues to grow nicely as well. So a lot of growth ahead in the data center, which is going to consume a lot of fiber, but a lot of fiber connections to connect all of these powerful servers that are being deployed. The next slide. And so to build an AI network, I thought I'd start with a short recall, Gary, from 6 months ago or so when I joined Fiber for Breakfast and talked about our focus on the 4 S's of innovation and why that matters to both fiber to the home networks and data center networks. What we've heard from data center operators that the speed to build a network is the #1 challenge they are facing. And AI is happening much faster than anyone expected, and the race is on to get these networks built. And so by bringing field labor challenges into our factories with plug and play terminated assemblies, that creates significant time savings and a much simpler installation for the field to deploy. This is very familiar territory, by the way, in building a fiber to the home network, where pre-terminated solutions enabled operators like Verizon and AT&T and many others to scale their deployment significantly through innovations like these. And the optical footprint measured in size and density is critical given the number of optical connections. For instance, our recent engagements with one hyperscaler in particular indicated a 1-to-1 ratio of server racks to optical patching racks in the data center. And what that means is that valuable real estate in a data center is consumed with racks full of patch panels and not revenue generating servers. And so hence the need to continue to shrink the footprint and create denser solutions to take advantage of the power and the space that's available today. And so lastly, leveraging our capabilities to shrink that footprint naturally creates a sustainability benefit by using less materials. If you can shrink the materials, the cables, the fibers, the connectors being used, we think our innovations, our next generation of innovations anyway, will result in more than a 50% carbon footprint reduction in the network that's being deployed. Okay, almost to the end. The next slide really is just to show a few of the optical componentry and solutions that are being deployed in a data center. And so to create the benefits that I mentioned on the previous slide, the industry is using what I'll call new keystone components, and that includes a new, smaller fiber. For instance, an example is our new 200 micron Corning contour single mode fiber, which is 20% smaller in diameter with superior bendability and low signal loss compared to 250 micron single mode fibers that have been deployed for the last several years. And these new fibers then enable a cable revolution, and with the ability to create much higher cable density and fiber counts while reducing the outer diameter of the cables. And lastly, then a new multi-fiber connector has been developed that miniaturizes traditional MT connectivity, 12 and 24 fiber connectivity. This connector increases the fiber density in the housing by 4 times over a traditional 24 fiber MTP connector, which is highlighted in the simple picture on the right. And this just simply shows the evolution from an LC duplex connector, 6 2-fiber LCs in a cassette in a housing would terminate 12 fibers. The second one is a 24 fiber MTP connector. I'm sorry, a 12 fiber MTP connector that's 48 fibers. So in that same space, you can see it's gone from 12 to 48 to 96 to 384 fibers are terminated in a cassette in the same footprint. And so that's a dramatic increase that allows and really plays on the density vector that I mentioned earlier. Okay, my last slide, just to close, is really that AI changes the game for data centers. Emerging AI architectures, they represent a step change in passive optical content in the data center. And at Corning, that's what we're focused on, and excited to be working with the world's largest hyperscale cloud operators to lay the fiber-rich foundation that's required to enable those AI applications. And just as importantly, we see this trend being a game changer in the access network, frankly. To use this powerful compute capability, it requires high bandwidth networks that enterprises and consumers can access to realize AI's potential. And so the work that this association and that we all continue to do to get the world connected is even more and more critical to ensure nobody or no country gets left behind. And so thank you, Gary. Thanks to the Fiber Broadband Association again for allowing me to share a little bit of insight on AI and the transformation that's taking place. And I'm glad with the time that we have left to field any questions.
Well, Mike, as always, this is fascinating. So can you help our audience understand kind of the correlation between the connectivity in the data center and the impact on the access network?
Yeah, it's similar, different products at the end of the day, but it's still the same components. It's still single mode fiber that's deployed in the access network that's being deployed in data centers largely. It's pre-terminated solutions. So if you think about connecting a fiber to the home network, buying assemblies that have connectors already put on from the factory really enables the speed of deployment. In the outside plant, they're hardened. They have to withstand the elements of weather and being buried in a handhole or cables and connectors being on the side of a house or on a pole. In a data center, it's a pretty benign environment, temperature controlled. And so there's some differences there in the products in terms of what they have to withstand in terms of the physical elements that the physical network is exposed to. But by and large, it's still the same componentry, just again, an indoor versus an outdoor environment. Pre-connectorized is happening now. That's been a trend in the data center for a long time with plug and play assemblies. But even if you think about those 3,000 fiber cables that are described in the interconnect, those are now leaving factories with connectors on the end to address really what's a critical constraint is skilled labor in the field to splice the amount of fiber that's needed both in the access network, data centers, and long haul networks. And so the more we can do that, the faster these networks can get deployed. And that's what's happening in both the access and the data center network.
Yeah, when I think about like all the GPT processing, everything that's going on in the data center, but as a user, so whether a business or residents, and you're on whatever AI application, Chat GPT or something like that, is that going to increase the capacity requirements for the access network, or is it all going to happen within the data center and alleviate? I mean, how's that? What's the correlation?
Yeah, I think it's like I think of it as a circle. The more capability and AI compute power that gets deployed in a data center, the more applications that will emerge for consumers using an access network. And as a result, more and more people that get connected, number one, that have access to a broadband connection and then a device to connect to the internet, are going to seek and use, whether at work or at home, applications that AI is certainly integral to. And so that access network is going to then feed more demand and more compute power that's needed. And that's why you see the megawatts or the AI compute continue to grow, is because the demand that consumers and businesses and enterprise and manufacturers are going to need is just going to continue to grow. And that's why I call it a circle. It feeds off one another, and more capacity in AI cloud compute servers means more applications get created, more bandwidth intensive applications typically that consumers use, and thus the need for more optical big pipes continues forward for the next many years to come.
What about increasing the capacity? So we're shrinking our fiber optics down, right, from 250 microns to 200 microns, and then more densely packing with ribbons and so forth. What about creating more capacity and leveraging wavelengths and so forth, so you're able to get more throughput over each individual fiber?
Yeah, we see a lot of activity on a number of fronts. At the end of the day, shrinking fibers to get more fibers in a finite amount of space, either more fibers in the same cable diameter or the same number of fibers in a smaller cable diameter to fit them in limited spaces that are available, is happening from 250 to 200. I think over the next 5 years, you'll see even smaller fibers, less than 200 micron. That still is a traditional single mode fiber that gets connected and spliced like 250 or 200 will. But wavelength, using more wavelengths certainly exists. That's WDM technologies existed for a long time. It continues to have a place to optimize existing footprint or existing fibers in the ground, perhaps. And then I think on the fiber side, you see things in some nascent technologies like multi-core fiber, where we're putting more cores in a single strand of glass to create more capacity in that fiber. So all of those are happening. The industry is actively working on that to create more capacity in a single mode fiber, whether it's more cores in a strand of glass or more wavelengths or shrinking the diameter of the fiber. All three, I think, will have a place.
All right, one of the questions that came in is, and this might be a little bit out of your lane, but can you speak the impact of AI on the fiber workforce? So is that, what's the impact on the workforce needs for fiber deployment?
Yeah, no, I think it is in our lane, because we understand, we are a maker and seller of fiber optic equipment. And if there aren't trained and skilled craftsmen to install fiber networks, then we aren't making and selling optical products. So we understand that constraint really well. I think at a high level, all I would say is the demand in the access network is equal to the demand in the hyperscale network. They both rely on folks that understand how to handle, manage, splice, and deploy a fiber network. And so there is a big constraint that continues in our industry of having enough skilled laborers to deploy optical networks, whether it's inside of a data center or in a fiber to the home in a small community. And I think, the thing that we are focused on, as I mentioned, is the more of that labor that we can put into the factory, ease the burden of having enough skilled workers, I think is going to be critical to ensure that both of these networks, the access and the AI networks, can be built like we want them to be built, at speed, with scale, sooner than later.
Yeah, I would say that AI would probably help a lot of the efficiencies. Like next week, we're going to be talking with Common Ground Alliance about locators and so forth. And, it's making sure that locators are there when you need it, when you've got your backhoe ready to dig. So I think those kind of efficiencies of making sure that we prioritize and got the people at the right place at the right time.
Yeah.
But Mike, thanks for joining us today. Always loved hearing from you and your insights and knowledge on AI and optical networking. So thank you. And I look forward to next week. So please join us next week. We'll have Sarah Magruder Lyle, the president and CEO of the Common Ground Alliance, who's going to be discussing increasing reliability by reducing dig-ins, fiber's critical role in reversing damage trends. So you're not going to want to miss that. And anyway, look forward to seeing you guys next Wednesday. Thanks, Mike.